So for number one, the goal is to solve for n. So let me add this n to this side. And when you add n to the right, it'll be positive n minus 5. Then now I moved it so I can get the square root by itself. You always want to get the square root alone if possible, because once the square root is alone, you can get rid of the square root by squaring. But of course, that means you have to do it to both sides, because the square knocks out the square root. So really it's just n minus 3 that falls. But here, that's n minus 5 squared, which is n minus 5 times n minus 5. So you have to expand this. So that stays the same. And here on this side, this is what we get. And then what we can actually do is we can combine like terms here in the middle. That'll be negative 10n plus 25. Then you can subtract 1n minus 1n, because there's a 1 right there. And we can multitask by adding 3 to this side. And we've done this because these are gone, and now there's a 0 on this side. And so here it's n squared minus 11n plus 28. Let me just reverse the order of this equation. Whenever there's a 0, I just prefer to have the 0 on the other side. And now this quadratic equation, we can actually factorize this. If you look at the numbers and if you examine them, the factorization for this should be, it should be n minus 4 times n minus 7. And I know this is correct because if you distribute like that to this, you'll get the previous statement. And the reason that this is better than that is because now it's something times something equals 0. So you set each of these pieces equal to 0. So you set that factor equal to 0. You set this factor equal to 0. You solve and solve each little equation like in the previous video. And these are the two proposed answers. But now you have to go to the original equation and check them. So let's see. Let's pretend that let's check. Let's check the answers. For n equals 4, take 4 for n and plug it in there and there. That'll say negative, and in the 4 plus square root 4 minus 3 equals negative 5. Well, this is negative 4 plus 4 minus 3 is 1. Square root of 1 is 1, like that. And this is negative 3. But the problem is that negative 3 does not equal negative 5. So n equals 4 was false. That is your extraneous solution, right? The only hope we have left is 7. So now let's take 7 and plug it in there. So let's check n equals 7. And let's see, so that would be negative, and then the 7 plus square root. 7 minus 3 equals negative 5. So this would be negative 7 plus the square root of 4 equals negative 5. The square root of 4 is just 2. And look, this actually worked out, right? So look, because that's a true statement. You know it works because the statement is true. You know it's extraneous or false because the statement is not true. So this one is money in the bank. So the goal was to solve. We have final answer. Here or there, doesn't really matter. Just tell them that this is the one only solution. Now look, sometimes they both work. Sometimes they're both no good. You never know what's going to happen, which is why it's important to check your answers. For number 2, notice that the square root is already by itself. So I am ready to square both sides. So I just copied it again, but now let me square the left and the right. Now over here, n minus 4 squared is n minus 4 times n minus 4. On the other side, the square is going to knock out the square root. So it's just this stuff there. Now if you distribute, it'll be n squared minus 4n plus 16. Okay, so I sort of skipped a little baby step there. There should have been like a negative 4 and a negative 4, which gives you a negative 8. And then now, why don't we move these pieces to the other side so that there's a 0 on the right. So I'm going to add 3n. I'm going to subtract 40 because these are gone. And this will be n squared. And let's see, this is going to be negative 5n. And that's going to be negative 24. Check on a calculator just to make sure, but that should be it, I think. And now look, we have another quadratic. And I believe that we have the ability to factorize. And if you consider the numbers, this should be the factorization of that, right? These two pieces. Set each piece equal to 0. And then solve. And the two proposed answers would be positive 8 and negative 3. You want to check them, of course. I'll let you do that if you want to. But just by looking at this, I can tell you that this one is going to be the extraneous. So that's not a good answer. And this one is going to be money in the bank. I can tell you that 8 is going to work out. Not because it's positive, right? The negative answer doesn't mean it's false. You never really know what to expect. So plug them in carefully and see what happens. You'll see that this one's no good. And this one is cash money. All right. Here, I want the square root alone, so I'm going to move the 3 to the other side. So if I move the 3 to the left, it'll be r minus 3. And then the square root will be by itself. And now is a good time to square both sides. So over here, it's r minus 3 times r minus 3. And here, the square knocks out the square root. So it's just the stuff inside. Here, if you expand it like we did before, it will say this. Watch, it'll say this here. And now is a good time to create the 0 on one side. So let me subtract 6r, and I'll multitask by adding 23. So these are gone, and there's a 0 here. Now, careful here. It's tempting to cross these out, but nuh-uh, that's the negative 12r, right? So we've got to be very careful there. It's a negative 12r plus, is that 32, right? That's 32 equals 0. And then look, another one, another quadratic. So you see there are trends, right? These problems tend to be somewhat predictable. They follow a certain pattern. And if you factorize this, I think 8 and 4, r minus 8, r minus 4, this should be the factorization of that. If you check that, that should be it. Set each piece equal to 0. Solve. So we think the answers are 4 and 8, but check them. If you check 4 in there, 4 is going to work. I'll let you check it, though. If you plug in 8, that's also going to work. So here's an example where they actually both worked. And again, they work because if you plug in 4, it'll be something that's a true statement. Plug in 4 there, work it out. If you plug in 8 there, it'll be a true statement. Yeah, it'll be a true statement. So they both work. So that's nice that it's a little different. Now, how about here? This is completely different. So here, this is called an exponential equation. So look, that's 10 times 4. That looks like it's 10 times 14, excuse me. It looks like it's 10 times 14, but it's not. You see, I fear that some students are going to call that 140. But no, because that's not 14. That's 14 to a certain exponent. So what we can do, let me write it down again. What we're going to do instead is we're going to get rid of the 10 altogether by division. These are gone. And I use division because these are being multiplication, these are being multiplied, and the inverse of multiplication is division. So if I divide by 10, now it's really just 14 to this power. And then over here, 21 divided by 10, you can leave it a fraction. I'll just call it 2.1 because that's exactly what it is. Now look, I'm not sure how your teacher taught you how to do a problem like this, but one thing that you can do is this. You can actually take, let me write it down again. What we can do is we can take the log of both sides. I am going to take the log of the left, and I'm going to take the log of the right. And the reason I've done that is because if you look through your log properties, I'm assuming you guys have learned logs. If you look through your log properties, there's a log property that says this. Log a to the power of b equals b times log a. So there's a property that says that if you have a little thingy there with an exponent, that exponent can come to the front and become a coefficient. And that's what we can do here. I'm going to take this exponent, which is like the exponent there, and I'm going to move it to the front so it becomes a coefficient. So this little purple bubble, it's going to go right there. That's just one of the properties from logs. And if you do that, it'll be 3x minus 10 in parentheses times log of 14 equals log of 2.1. What are we trying to do? From the very beginning, we've been trying to solve for x, and we can get x alone. What I would do, I would divide both sides by log 14, because these knock out. So I have 3x minus 10 equals log 2.1 over log of 14. Now I want x alone, so let me add 10. So these are gone. And then let's continue up here. Let's finish up here. So these are gone. So it's just 3x equals log 2.1 over log 14 plus 10. Now to finish this problem, what you can do is you can divide both sides by 3. But since this looks kind of weird, instead of division by 3, I'm just going to multiply by 1/3. I'm going to multiply by 1/3. It's the same thing as division, right? So these are gone. And now x is alone. And so here is our final answer. Now let me just throw this at you before we move on to the last question here. Does your teacher want an exact answer, or do they want you to round to the nearest whatever? Because this actually is the exact answer. This has not been approximated in any way. If you want an approximation or if you want to round, type in this gibberish into here and just round however they want you to. But as is, this is the exact solution. And this can take many different forms. I could have written this in a different way, but it would have had the same value. So as is, that's one legitimate answer. Now for the last one, this is not an equation. All the other ones we did, these are all equations. This is an expression. So I'm assuming the goal is to simplify. So let me show you what I would do to simplify this. When I first saw this problem, I saw a power of 0, and the 0 applied to this parenthesis. So this stuff to the power of 0 is 1. So this here just becomes 1 times, and then I'll keep everything else the same. So it's kind of nice that it had a power of 0 because it just turned everything into 1. So that can essentially be ignored. I'm going to ignore it. As a matter of fact, I'm going to write this again because you don't have to write the 1. Because 1 times this stuff is just the same stuff. Now look, so here's what we have right here. Now you see the b, it has an exponent of 1. And I emphasize it because the power of 4 applies to everyone inside, and you sort of kind of have to distribute the power of 4 by multiplication. Power, power, you multiply. Power, power, multiply. Power to a power, you multiply. So the numerator would be b to the power of 4, a to the power of 12, c to the power of 16. And I'll leave the bottom the same for now. Now, one thing that has to be addressed right now is the negative exponent. So what I'm going to do is this. Watch what I do. I'm going to write everything exactly the same. That should say c to the 16. Little typo. And then 2b, look, that has to be dealt with. We don't want to play with negative exponents. So what I do, in order to make the 2 positive, this little piece is going to move. Instead of the bottom, it's going to come upstairs to the top. And when you move it to the top, the exponent would switch sign. So instead of -2, it's going to appear in the top as a +2. You see what I'm saying? So everybody else stayed the same. It's just this came to the top and the exponent switched from negative, boom, to positive. And now that it's upstairs, it has a best friend with the other c. These are best friends, right? Because it's the same variable. So what we can do is you can combine these two c's into one by adding the exponents. So that'd be c18. Everything else stays the same. And now the only thing left to do is to simplify the b's. You see, b to the 4th is like 4 b's, and b in the bottom is just 1 b. So really, if you wanted to, that's really b4. And this is a12, and this is c18. And the reason I expanded it to 4 b's is so you can see that this one knocks out this one, right? So really, all that's left on the top is 3 b's, an a12, and a c18 over 2. And I can't help but feel the need to alphabetize. So it's a12, b3, c18, all over 2. Final answer.